All right, optimization. Now, I'll pre-warn you about a few things. Optimization is what a lot of students consider to be quite a hard topic. So the example that I'm going to use is an easier optimization problem. Expect that at like a year 12 level, you will get problems that are harder than this for optimization. But I just want to give you a nice intro to the topic rather than doing something which is overly difficult more than it has to be, especially if you're just getting used to what the concept of optimization is still. So first step is to draw a large clear diagram of the situation. We have this farmer, and the farmer has some sheep. So the farmer has this existing wall here, and they're trying to build a sheep pen along there, and they've got 100 meters of fence to do it. So the perimeter is 100. So they only need to build 3 sides, as the 4th is an existing wall, and sometimes I even cross off information as I use it. Rectangular would mean that these two are the same lengths, and let's just call this maybe Q. All right, find the largest area they can build. So basically, first thing we need to do is figure out what Q is. So Q plus X should equal 100. So that would be the perimeter minus that other wall. Therefore, Q plus 2X is 100. Therefore, Q is 100 take 2X, just like that. So now, instead of writing Q on this diagram, I can write 100 take 2X whenever I see it. Next, all right, we've drawn the clear diagram. Construct a formula for the variable to be optimized. Everything you do should only have one letter in it. Usually it's X. The area, well, it would have been X times by Q, or length times by width. So I'm going to write this as X times by what we figured out Q was 100 take 2X, just like that. All right, I might expand it 100X take 2X squared. That'll give me the area. Now, it's not a bad idea as soon as you get this formula to write it in your calculator. So let's just do that. 100X take 2X squared. Sure looks like a function. On optimization problems, X and Y usually don't go negative because we're dealing with the real world. I'd be a bit concerned about our happy little sheep in this pen if the area was negative. I don't think it would be too happy. So keep everything positive. X, well, 24 seems appropriate for that length maybe. Could be a bit longer. Now Y is going to be the area, because remember when we look at a graph of this thing, you're not graphing X and Y. You're graphing X, which is in meters. That's the length of the fence there. And you're actually graphing area. So if we just throw out rough numbers for the area, like, I don't know if that was 50, for example, well, that would be a pretty bad pen. But let's just suppose 50 times 50 is about 2,500. Maybe let's make Y about 2,000. See how big that area can get. All right, good. So we've got the Y right. X needs to be a lot bigger. So go up to 50. Or maybe even let's go up to 60. Just a little bit more room. There we go. So the whole point of this problem is going to be to find that maximum. I mean, there it is. And one thing that I want to point out is the way these questions are written is usually this thing here is like a show that question. So the tests and exams are usually designed so that you can still do part B and C even if you didn't get the part A, which was the show that. So basically a graph looks something like that. What we need to do now is find the first derivative and set it to 0. So a dash of x equals, well, I'm going to try and set 0 equal to a dash of x. And a dash of x is 100 take 4x. So 4x is 100, or in other words, x is 25. So this is what we call our critical point. We also need to find the endpoints for the situation. So if you think about how small x could be, x equals 0 is how small that could be. And then this pen's going to look very flat. And you sort of go across there. I would expect the area to be 0. And also that width would be 100 meters because the farmer's using all that fence there. And the sheep is very unhappy because they've just sort of been squashed into that little pen, which has 0 area as well. If you think about how big x could be, x equals 50 is as big as this gets. So if we look at x is 50, then that would be 0 meters along there. And again, the area would be 0. So you've got to think about your realistic endpoints, 0 and 50. All right. So we've done all this stuff. We've found our critical points. Use your formula from 2 and plug in all the x values of your critical points and your endpoints. So you have to do both. So x equals 0. That's the first point we're going to plug in. A of 0 is 0 meters squared. X equals 25. Area at 25 is, now we already found it before. It's 1,250. And x is 50. The area at 50 is, let's see, 0. Now we probably should check that. So if I go trace and I type 50, I'm going to get 0. And if I go trace and I type 0, I'm going to get 0. And if you don't want to use trace, you can actually plug it back into that area formula there, and it should all work out. So I think it's hopefully clear enough that this is the max area possible. And if we wanted the minimum areas, not that this question was asking for it, there are 2 ways to get the minimum area. It's those situations. So you could give like a sentence answer, something like this. Max area is 1,250 meters squared when it looks like, so x was 25. So we're going to put 25 meters there and 25 meters there. Knowing that the whole fence had to add up to 100, that would have to be 50 meters there. Or if you're not sure, you could use 100 take 2 lots of 25 would give you 50 as well for that Q value. That's pretty much all there is to it. Be aware that you can do a lot of this on your calculator. Like if you can't do the calculus, you just go Gsolve max and then you write your interpretation. But to get full marks, you'll usually need to show you're working with this derivative stuff and then checking both of your endpoints and your critical points. And just to be really clear, the reason that you might want to check your endpoints is if you're trying to maximize something, but your function looked like this. Basically, if you'd only checked your points there and there, your critical points, you'd be missing the actual maximum, which is sitting over there on your function. So you just got to be careful about that.